Hello everyone, you are welcome in polymorphism session. This is one of the most important pillar of OPS concept in Java. So let's dive in this topic. So first polymorphism. Polymorphism comes from the Greek word which means maniform. Means polymorphism means maniform. Means one thing can do multiple things. Means in terms of Java, one method name can do multiple things. Means method name will be same, but it performs different action as per requirement. So Java supports two types of polymorphism. First one is compile time polymorphism and second one runtime polymorphism. So first let's understand compile time polymorphism. So compile time polymorphism is also called static binding or compile time binding, and method overloading is an example of a static binding or compile time polymorphism. So first understand what is method overloading. So method overloading is a way of writing multiple methods with same name in the same class with different signature. So what do you mean by same name with different signature? So suppose we have a calculator and it has a calculate method. So here is a one chance like that we can calculate only two variables. Suppose we have x and y. In second method perform the same action like calculate. Suppose we want to add the value of two variables. So instead of calculate, suppose we have a add method. So one method has int x and y. In second method we want to calculate x, y and z, and in third method we want to calculate something else. Suppose int x plus some default value we want to just add. So here all methods will do the same thing, means do the calculation, means do the summation. So there is no point to write different method with different name, because all method means all sum method or add method, whatever you can name it. So suppose we have add method, so all add method will do the same thing, addition, but its argument is different. So all those methods we will write in the same class with the same name, but argument is different. So here argument and return type is different, so it is called signature basically. So in Java we can change the signature of method using the method argument, but just cannot change the signature of any method by returning the different value. Suppose we have add method, it return one add method returns int, second add method returns float, and third method returns double. So Java, but argument are same in all three. Java does not support that kind of things. Java supports by means in Java you can change the method signature with the argument only. So that's the thing. So if you declare any method multiple times with the same name with different signature, this is called method overloading. Means you are overloading the same method multiple times, means doing the same thing multiple times with different argument. So this is called method overloading, and it is also called a static binding and compile time binding. Why it is called a static or compile time binding? Because compiler bind the method with the object at compile time, means you cannot change at the runtime. Suppose we have a three methods. First method just takes two arguments and you have called that add method. So at the runtime you cannot change another method which has three argument, or third method as suppose takes two value or maybe four argument. So runtime you cannot change the method, means calling method you cannot change, there is no way to change at the compile time. So things are resolved at compile time, means when JVM compile the code, that point of time only method is bind with object reference. Even object is created at runtime, but method reference is bind at the compile time only. So in method overloading we cannot change the method at runtime, so it is called compile time binding, means methods are bind only at the time of compilation of the code. So it is also called a static binding. And another thing is that method overloading. So method overloading is also called dynamic dispatch, dynamic binding, or runtime binding. And this runtime binding can be achieved by overriding the method. So in this we have a inheritance, means in inheritance relationship is required to support method overriding, but in case of method overloading you don't need inheritance, means in compile time binding only single class is responsible, means in the same class we declare the method with the same name multiple times with different argument. So it is a compile time polymorphism, but in runtime polymorphism in inheritance is mandatory. So in this we override the same method in subclass with different implementation. Suppose here you can see in a screen, suppose we have a payment class and another class is UPI payment, it extends payments and it again override this payment method. So what is the purpose of overriding this pay method? Even without overriding, this UPI method can get the access of payment method, payment class pay method, because it is in inheritance relationship. But why again this same method is written in subclass? So here purpose is that if subclass, suppose we have payment and payment can have n number of subclass, like one class is UPI payment, another class may be Google Pay, next some other class like Paytm payment and other interfaces like. So but payment is common and all subclass of payment will have this payment method, but all subclass of payment will not have same implementation. So what's happening in real time Java application, if something is common, then that functionality we write in superclass and all subclass will use that common functionality. But any class, if it needs a specific implementation and a specific logic, then we override that method to provide the specific implementation. So that's the purpose of overriding the things. So again I am repeating this thing because it's super important to understand dynamic polymorphism or dynamic dispatch process. So in this, if we need a specific implementation, some unique implementation, then we override the method. If we don't need a specific implementation, then we can just call superclass method. Then in these cases we will not use override. So here polymorphism that way provide two types of polymorphism, and purpose is that to do the things at compile time and runtime. So runtime is quite useful because it resolves the things at runtime. Even compile time is also used, but runtime is very frequently used, and interviewer usually very interested in runtime polymorphism because it is a quite complex things. So you also have to put the some effort in this. So let's move to the IntelliJ to understand the thing with the help of concrete examples. So here I have mentioned the theoretical parts also in this examples. So even we have already discussed, but to revise the things you can just stop the screen and read out and understand the thing what is a runtime polymorphism and compile time polymorphism. Here you can see that here is a three methods like add, but it has different signature, like first one has int a and b, second one has double a and b, and third one has three arguments. So this is a, and this is example of compile time polymorphism if we write all those things in the same class. So here method name is same, but its signature means argument is different. So this is called method overloading. And in runtime polymorphism means it is also called dynamic polymorphism, dynamic dispatch, or dynamic binding also. So in this we override the method through the inheritance. So here I have some examples. So first understand compile time polymorphism. So I have created one program like compile time polymorphism example 1. So here you can see there is a calculator class and it has add method, and you can see add is written 3 times, means it has 3 method but different signature, even 4 method, and number of, there is no such limitation. You can create a number of method with the same name but different signature, means with different argument. So here is 4 method. So this is example of method overloading, means compile time binding. So what is happen here? So you can see here I have a calculator method, calculator object I have created, and here it is called this add method which has 2 argument, and next one is passing 3 argument, and again this is passing type of double, this is a type of double. So this method will get called. So that way means this is bind at the compile time, means at run time there is no way to change this calculator, means this calculator currently calling this method with 2 argument and type is integer, but at run time there is no way to call this method or this method. So it is fixed basically. So because of that it is called a static binding, means at the runtime we cannot change it. And just let's run this program. So I have run it. So this method, this one will call this method because its type is integer, and here I am passing integer, and this has 3 argument and its type is integer. So here it will, this method will be called, but this one has floating point value. So for in this case it will call this method double because even it has 2 argument and integer has also 2, but type matching with this one, so this method will be called. So this is a tricky part. Interviewer will ask which method will be called when and where. And this one is first argument has integer type and second argument has double type. In these cases this method will be called. So this is a good example of method overloading. Now I am moving to next program related to like area calculator. So here you can see I have a class and it has three methods, 4 methods. One is like it calculates the area of anything like side into side, means a square, it calculates the area of side, because inside in a square, if anything in shape of a square, so to calculate the area you just have to multiply the things twice. So side into side, it returns the area of a square, and if you multiply length and width, then it will return a rectangle area. Similarly, triangle has its own formula, circle has its own formula, it's a maths formula only, but all are doing some calculation, area calculation, but it's all has different implementation. So these are the examples of compile time polymorphism, and here you can call this method. So I am just running this program, so you can see here. So I hope you understood this compile time polymorphism. Another example again I have created for this one, like this is for ticket price calculator. I need to calculate the price, and we have overloaded this calculate fare method multiple times as per requirement, and it will perform some calculation with different argument. So now I am moving to runtime polymorphism. So here is an example like payment. Suppose we have a payment system, and this super class means payment class has pay method, and all other subclass just override this method. Override keyword is optional, it is a special keyword provided by the Java. So even if you don't mention, still it will work the similar way. But there is one thing, if you mark anything override, then that method must be exist in super class. Suppose pay is a method here, but if you make it pay1, then it will give error, because pay1 is not exist in super class. So but if you remove this override, it will not complain. So in this case, what will happen, in this method will be totally different. So whenever you will call API payment.pay, it will call superclass method, because there is no pay method in subclass. So if you truly want to override any superclass method, then you can use override, but it's optional. But it's a good practice to use override to avoid the error. Sometimes what happen, by mistake you write some method, means typo error or anything you can do at real time, but your intention is to overriding the method. So to avoid this kind of typo error or unintentionally or intentionally, you just use override. So it will tell you upfront. So here is payment, and I have overridden this pay method in multiple class. This is UPI payment, card payment, and net banking payment. All three subclasses overrided this pay method. And at runtime, you can see here I have a payment, and payment is a reference of payment. This is the super class, and if runtime, if you pass UPI payment object, then it will call this method, UPI payment method. Even when I click this one, it will always call super class pay method, but at real time, means when program will run, it will call the pay method based on object. So suppose here I have passed UPI payment, then here means payment has object payment has UPI payment object, then it will call UPI payment pay method. And similarly here payment now again reassigned, and it has now card payment, then this payment dot pay will call card payment method, means this method. And similarly it works for others. So runtime you can decide, means what object you will assign to object reference. This is the payment is the object reference, and real object is this one. So runtime, if you pass the object of any subclass, then that subclass method will be called. So you can decide it at runtime based on requirement. Suppose UPI interface send the request to the backend system, then you will create a UPI payment object, and then this same code, this pay method will call UPI payment ecosystem. And if you pass card payment object, then same method. This is the same, but if you change the object on fly, it will call different method. But same thing is not possible in compile time. So that's the major difference. So this is a good example of runtime polymorphism. Let's move to another example. Here I have a notification, email notification, same SMS notification and push notification subclass. So we have multiple subclasses and one superclass like notification, and it has send method. So we have overridden this send method in all subclasses, and at runtime it will be decided. So here again similar way like previous. So notification here assign email notification object, then it will call notification send method, similarly for SMS and for other classes. So now again I am running this program and you will see. So here this one will call email class notification method, and this one calls SMS notification method. So this one is the output, and last one is push notification, so it will call push notification message. You can see here this one. So first one means this code at line 49, it will call this one sending email notification, and similarly it works for other. So this is another example, and also similar way I have written another examples like circle, rectangle, shapes and other things. So shape is a super class and all others are subclass, and it over all subclass override this draw method, and all method means this draw method has different implementation. Suppose if you have to draw the circle, then this circle method will provide the specific implementation. To draw the circle it require round shape like that, and its rule and regulation is different, area is different. So thing is that same method has different behavior, means same method has many form. So it is called polymorphism. Polymorphism exact meaning is many form. So same method have many form, means it perform many tasks at runtime, and it totally depends on object. So here I have a 3 subclass of shape, and all means passing the object, and based on object methods get called. So I am running this program. So as per object it's called the method. So here this method is called circle, rectangle and triangle, means as per object it's calling. So these are the things about polymorphisms. I hope you understood the things. What's the difference between runtime polymorphism and compile time polymorphism, and what is polymorphism. So just I am repeating the things quickly. Polymorphism, there are 2 types of polymorphism, compile time and runtime polymorphism. Compile time polymorphism means method overloading is an example of compile time polymorphism. In this, we cannot change the method at runtime, and in this compile time we create multiple methods with same name in same class with different argument. That's the way of creating the method to support method overloading. And in runtime we have a inheritance relationship. In the superclass, method will be rewritten in subclass, but inside this subclass logic is different, means a specific implementation for that particular things. So that is a runtime examples of method overriding, and it is also called method means dynamic dispatch or method runtime polymorphism. So these are the things. So I hope you got the things. So thanks friends, we will meet in the next session. Thanks for now.